Welcome back to page 2 of 2.1 quadratic functions. So we are going to continue on with the second page of notes for this. So we're going to be using a lot of the same information that we talked about from page 1. So our first examples on this say to identify the vertex in the equation of the axis of symmetry, then write the quadratic in vertex form. Now, you just did this on that example where we were writing it in vertex form. I'm going to do one with you. So let's try that one out again. First thing, just like I did before, is identify my A, B, and C value. So in this case, my A value is -3. My B value is 12. My B value is 12. And then my C value is, 5. I don't know why there's an F there. So we can ignore that. So once you have that information, it's easy to just plug into our vertex formula. So our X value of our vertex is our H value. And so our H value, if you recall, that formula is opposite of B all over 2A. So we're going to start there. H is equal to the opposite of 12. So it was positive. Now it's going to be negative. Divided by 2 times A. And our A value is -3. So that gets us a -12 over a -6. So my H value, or my X value of my vertex, is equal to +3. No, +2. Whew, okay, we're having some moments. I don't know why the whiteout is just not working. Okay, so it's equal to +2. Sorry about that. Okay, so now that we have our H value, we can use this to plug it in to find our K value. So our K value is going to be equal to -3. The 2 goes in for X, so 2 squared plus 12 times 2 plus 5. Now, like I've said many times before, I just do this whole thing in my calculator. So -3, 2 squared plus 12 times 2 plus 5 gets me a +17. If you want to do it out, you're more than welcome to. Remember, when you do that, that's 2 squared, so 4, and then 4 times -3 is -12 plus 24 plus 5. So it gets us still, either way you do it, a K value of 17. So now that we have our vertex, we're just going to write that in our first spot. So we have our H value, which is our X value, and our K value, which is our Y value. Now that we have our vertex, axis of symmetry and vertex form should be very easy and straightforward to do. So if you guys recall from the first page, to solve for the axis of symmetry, we look at X equals opposite of B over 2A, which is the same as the X value of the vertex. So all we do is look at the X value of the vertex and we write it as X equals 2. So there's really not much thought in that one. As long as you have the H value, that's always going to give you the axis of symmetry. Now, again, remember, you do have to write it as X equals. You can't leave that part out, or else you're not writing the equation of a line, which that's what the axis of symmetry is. The axis of symmetry is an equation of a line. And then vertex form, we have our A value, which is -3. We have our H value. We have our K value, so I can just plug it in. So A is -3. X minus, remember it's the opposite sign, so it's -2 squared plus the H value, 17. And that is that. Okay, so what I would like you guys to do, so on 2, I want you to do as much as you can and then come back and check your work. When you come back and check your work, I'll kind of go through a little bit more quicker, like how to do the problem, but pause the video right now, try 2 on your own, and then come back and check your work. Okay, so hopefully you are coming back to check your work. You've tried it. So going through, my A value is -1. My B value is 6. And then my C value is -8. And so I can just start plugging that into my formula. H equals the opposite of B, so opposite of 6, divided by 2 times A, which is -1. And so that gets me -6 over -2. -6 over -2 gets me a +3. And that's my K value. So now that we have our K value, now we're going to plug that in to find our H value. Our K value. So our K value, we're just plugging it back into this original equation. Now be careful with this. When I plug in the 3, if I wasn't doing this in the calculator, which I'll also show you in the calculator, you're doing 3 squared, you're doing your exponents first, and then you're multiplying it by the -1. So this would ultimately end up to be -9. But like I've done before, I would do this in my calculator. So I would go negative parentheses 3 squared plus 6 times 3 minus 18. And that gets me -9. Oh, it's -8. Whoa. You guys, it's a Sunday and I'm making this. I don't know. I'm catching myself though, so here we are. Okay, let's plug that back in. I would rewind and cut this out, but let's be honest, it's more fun with me not. So, okay, so we get our K value of 1. And now we have our H value and we have our K value. Okay, and so now I have my ordered pair. So 3, 1 is my vertex. My axis of symmetry is just the H value. Remember, you have to put the X equals. So X equals 3, always one and the same. And then vertex form is going to be negative. If you put a -1, that's totally fine. X minus 3 squared plus 1. And that is your quadratic in vertex form. Okay, on to 3. Okay, so now what 3 is saying, it says, given the quadratic function below, find the x and y intercepts. So with this one, if we go back to our first page of notes, it says to solve for the x-intercept, also known as yada, 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 we either factor or use the quadratic formula. And then to solve for the y-intercept, you can plug in 0 for x and solve for y. Or it says when in standard form, you can look at the c value. So the y-intercept here is probably the easier one. So let's actually start with the y-intercept. My y-intercept, my c value is equal to 5. And so my y-intercept here is just exactly that. And remember, that's my y value. And so my x value is 0, my y value is 5. So it's 0, 5. If you wanted to plug in 0 for x, then you'll still get to the same thing. And it's the same idea, right? This is the y-intercept is where x is equal to 0. That goes away because anything times 0 is just 0, and then we're just left with the c value. Okay, then let's do the x-intercepts. So the x-intercepts. Now, I always am thinking, can I factor this? So when I do that, I'm thinking, what are 2 numbers that multiply together to get me -15 and add to get me 12? So I kind of just do a quick trial and error to see if I can factor it. So I'm thinking, okay, -15 and +1. No, that doesn't work. -5 and +3, or some variation of that. No, that doesn't get me 12. So this is probably not factorable. Now, even if it was factorable, you can still use the quadratic formula. Both should get you to the same point. So the quadratic formula will like always work, but sometimes I just think factoring is easier if you can. Okay, so we're going to use the quadratic formula because we can't think of our two factors off the top of our head, and it is not factorable. So that would be the opposite of b, so the opposite of 12 plus or minus b squared minus 4 times a, which is -3, times c, which is 5, all divided by 2 times a. So with this, you're not just getting decimals, so we can't just plug this whole thing into our calculator. So I kind of do this piece by piece. The first thing I do is I figure out the value inside the square root. And so that would be 12 squared minus 4 times -3 times 5, which gets me 204. And then divided by -6. Now, I do want you to reduce the radical if you can. And so what I would do and how I do that process of reducing the radical is I really am looking for like what's the biggest perfect square that goes evenly into 204. So your perfect squares, remember, are, I'm just going to write it quickly. So your perfect squares are obviously 1, but we're not thinking about 1, but 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, and so on and so on. So when I'm like going through 204, there's a few ways that you guys can like decide if you can simplify this or not. Like I just basically do trial and error with those numbers. So what I would do in my calculator, I know it's not gonna be 100 or higher, because 100 is like too close to it, and I know it doesn't go in evenly. So basically I'd start with 81 and just kind of go down from there. So, and I go from the highest to the lowest, so I make sure that I'm simplifying it as much as I can. And like I said, it's just trial and error. So 81 doesn't go into it, so I'm going to move to 64. It doesn't go in. I'm going to move to 49, and I'm going to keep going until something goes in evenly. And I know this is a pain because what ends up happening is it's going to be 4, and then it's 4 times 51. And so I think about 51, especially when it's that small, like when it's 4, I think, well, 51, can I break that up? But I can't. 51 is a prime number. So the way that we simplify that is we would write that as -12 plus or minus the 4. We think, okay, what's the square root of 4? That's 2. And then the 51, the value that we can't take the square root of, stays inside. Now, with this, there is actually one more step that we can take to simplify this completely. So if you look at your outside numbers, and what I mean by my outside numbers is the numbers that are outside of the radical. So if we look at -12, +2, and -6, I think, are those all divisible by the same value? And the answer in this case is yes, they are. They're all divisible by 2. Now, because -12 and -6, they're both negative, I'm actually going to divide everything through by -2. And so -12 divided by -2 gets me a +6. Now, why I do that is because this is a plus or minus. So a +2 divided by -2 turns negative, but a -2 divided by -2 turns positive. And so the plus and minus in the inside doesn't change. And then -6 divided by -2 gets me a +3. Now, you can write this one of two ways. You can write this as just x equals 6 plus or minus rad 51 all over 3. or if you wanted to write it as an ordered pair, which you totally can. So if you wanted to write this as an ordered pair, that's probably where the F from up here went missing from copy and paste. Okay, so if you wanted to write it as an ordered pair, sorry, I got sidetracked. You could, but it would be like, it's not worth it to me, but you can. So it would be 6 plus rad 51 all over 3 comma 0, because this is our x value, and then 6 minus rad 51 all over 3 comma 0. And also, if I were to say graph these, you could also do that in your calculator to get the decimal, because let's be honest, you don't know what those values are on a graph, so we do have to get the decimal. If I said get the decimal, I would just do 6 plus rad 51 divided by 3, and that gets me approximately 4.38, and then do the same thing. 6 minus rad 51 divided by 3 gets me negative 0.38. So that's kind of the process if you wanted to do like this is this as ordered pairs. But again, you can just write it as x equals. Okay, so what I would like you guys to do is pause me here, try 4 on your own, and then come back and check your work. Oh my gosh, there's the F again. I was not having a good time when I was copying and pasting this. What a mess. So I'll have to fix all of that. Okay, so try 4 on your own, and then just start by finding the y-intercept, come back, check your work, and then kind of pause me again and try the x-intercepts. And if you need me to walk you through it, then, don't pause and just have me walk you through it. But do try find the y-intercept on your own. Okay, so hopefully you have an idea of what the y-intercept is. The y-intercept with this one, again, it's in standard form. So all I have to do is identify the c value. And in this case, the c value is negative 8. And so my y-intercept is just 0, negative 8. If you put y equals negative 8, that's fine too, as long as I don't say write it as an ordered pair. If I do say write it as an ordered pair, then I do want you to write it as an ordered pair. But if I don't, then it doesn't matter to me. Okay, so the x-intercept, if you want to try the x-intercept on your own, try the x-intercept on your own. If you're thinking about factoring, you can factor this one, but I would recommend factoring out a -1 first, and then factoring what's left inside. So if you want to pause and try the x-intercepts, great. If you want to just wait and watch me go through it, then that's great too. So you can, of course, use the quadratic function for this. Now, what will happen is you will get a perfect square inside the radical. You get a rad 4 inside the radical. So then you'd have -6 plus and minus 2, because the square root of 4 is 2, divided by -2, and then -6 minus 2. And so you'd actually go ahead and get those values. But you can also factor this. So what I was saying is, so if we have this, and again, your x-intercept is where y is equal to 0, which is your f of x. So y is equal to 0. The first thing I would do is actually factor out this -1. The reason I would do that is because if you have an a value that's equal to 1, you can go straight to the shortcut. But if it's anything else, even if it's -1, you can't go straight to the shortcut. So that's why I'd factor out a negative first and then go into factoring, like the inside what's left next. So at this point, I'm thinking, okay, do I know two numbers that multiply together to get me +8 and add to get me -6? And I do. It's -4 and -2. So we still want to put that negative, but at the end of the day, that negative is actually not going to matter to us at all. And so what's going to happen is you can really think about this as a -1, and you're going, okay, -1 equals 0. There's no variables here for me to solve for. So you can just ignore it. And what we end up just doing is having x minus 4 equals 0 and x minus 2 equals 0, and I get x equals 4 and x equals 2. Now, like I said, you should get these values if you use the quadratic formula. But if you do it that way, like I said, what you're going to get is something like this. So if you use the quadratic formula, you'd get negative 6 plus or minus rad 4 all over negative 2. And so the square root of 4, we know the square root of 4. So we have negative 6 plus or minus 2 over negative 2. And you have to then continue solving. So it'd be negative 6 plus 2 over negative 2 and negative 6 minus 2 over negative 2. So that would be negative 4 over negative 2, which gets us that positive 2, and negative 8 over negative 2, which gets us that positive 4. So either way that you guys do it, you can, like, if you don't want to factor, if you don't want to have to worry about factoring, you can literally just use a quadratic formula every single time, and that's totally fine with me. It's just I want you to recognize if you can keep simplifying, keep simplifying. Okay, so let's move on to 5. So 5 says, write the vertex form of the equation with a vertex at 1, 2, and passes through the point 3, negative 6. So it's asking us, it's giving us the vertex. So what it's giving us is the h and k value, right? That's our h value and our k value. And then it's saying it passes through the point 3, negative 6. So it's giving us an x, y value. And now it's saying, okay, write the equation in vertex form. So vertex form we know is f of x equals color blue a times x minus h squared plus k. So for vertex form, what we're really missing is a. But if you look, we have basically all of the correct, like all of the information that we need. We have our, we have an h, we have this, we have our k, too. So that's going to go here. And then I'll just use the same color, but like for x, that would go here, and y is the same as f of x. So we have everything except h. So what we're going to do is we're just going to work backwards to first solve for a. So work backwards to solve for a. Okay, and so that's exactly what I'm going to do. So in for f of x, remember f of x and y are the same thing, so we're going to plug in negative 6 equals a. We're just going to leave as a because that's what we're solving for. X, which I'm going to plug in as 3, minus, remember that's built into our equation, so we're going to go minus our h value, which is 1, square that, and then plus our k value, which in this case is 2. Okay, so to work backwards, we have to think about like our PEMDAS and order of operations. So first thing I'm doing is my grouping symbol, so my parentheses. So I'm thinking, okay, 3 minus 1 is 2, and then 2 squared is 4, and I'm just going to write 4a because we're so used to like having the variable second. If you put a times 4, that's fine too, but we're just at this point now, we're just solving for a, so we're trying to get a by itself. So to keep solving for a, what I'm going to do is I'm going to subtract 2 from both sides. I'll move my work up here. So that would be negative 8 equals 4a. Divide both sides by 4. And I get an a value equal to negative 2. So now that I have my a value equal to negative 2, I know that my h value is equal to 1, my k value is equal to 2. I can plug in what I have into vertex form and go from there. So that's exactly what I'm going to do. So f of x equals a, negative 2, x minus 1 squared plus 2. And that's my final answer. So all that you're doing with that one is you're given all the information. You just have to work backwards to solve for A. Because remember, for vertex form, just like we talked about on these, like the first page, you just need H, K, and A, and you plug it in. So we didn't have A, so we would have to work backwards to find that. Okay, so what I would like you guys to do is I want you to try 6 on your own. So pause the video here, try 6 on your own, and then come back to check your work. Okay, so hopefully you're coming back to check your work. So again, same idea, write the vertex form of the equation with a vertex at -3, 0, and passes through the point -5, -4. So I'm just going to write down vertex form. Again, I have my H value, I have my K value, and I have my X and Y. So I'm just going to plug that all in. For f of X, I have -4. I'm working to find A, and then X is -5, minus, and then it's minus -3. So what ends up happening is that becomes a plus. Don't forget the square, very common mistake. And then plus K, which is 0. So really what we're dealing with, the 0 goes away. -5 plus 3 is -2. And -2 squared is positive 4A, which we don't need the 0. So because 0 plus 0 is just irrelevant. Divide both sides by 4 to get A by itself, and I get A equals -1. And now I can write that in vertex form. Now, if you write negative, like if you write it like this, that's totally fine. And by that, I mean a few things. Okay, I got a little ahead of myself. If you write the -1 as the A, that's fine. But what I do want to see is that you recognize, like how I would write this is negative, and then X plus 3 squared, and then we don't need to put the plus 0. So really your vertex form is here. Now, if you had a -1 in front here, that's totally fine. I don't care if you put just negative or -1, that doesn't matter. But what, like I was saying, I want you to recognize that the K value or the H value is going to be an opposite sign. And then because the K value is 0, it shouldn't be there. So you shouldn't be writing plus 0. Plus 0 would not be written. And that's it. So that's it for the notes for today. We are going to continue on with 2.1 next week. So if you guys have any questions from the notes from today, you guys can keep them for Monday, and we'll go over them on Monday. But hopefully this is all kind of a review of Algebra 1, so hopefully it kind of came back to you. I know that probably 5 and 6 might have been new for some of you, but hopefully those were straightforward enough. But if not, we'll go over questions on Monday. Have a great weekend, and I will see you guys hopefully this weekend and, at homecoming. So, bye.